Well, I'm Radio Dan W7RF. I've been a ham now since March of 72, continuous operation, so I've been a ham 50 years. And my primary interest is HF operations, mostly DXing, a little bit of contesting, drag choose, all brain decode modes, skill-based stuff. CW, sideband, which still, even though it's voice and communicating that way, still takes some skill as far as timing and cadence and being able to go ahead and understand call signs, when to poke yours in, all that type of stuff. So this talk is supposed to be about propagation, and I want it to be an interactive thing where you can still ask questions, stop me when you need to, because sometimes if you have to hold a question to the end, you've already forgotten what it is that you wanted to ask about by that time. So when it comes to propagation, I think of HF propagation because there's propagation on all different either frequencies and or modes, but this one is mostly going to be about HF propagation. So the ionosphere above our planet is what does the reflecting of these waves, the short waves, say between 3 and 30 megahertz. 160 meters is a little bit different propagation, so let's kind of limit this particular part of it to 3 to 30 megahertz, 80 through 10 meters. And there's a number of different propagation modes that fall into that frequency range, and timing and all that kind of stuff. The study of propagation is just wonderful because it is unlimited and endless, because it's even like a pool table that's not just in 2 dimensions with round balls, but it's in 3 dimensions with round balls. So that's where the learning is just impossible to go ahead and have every morsel of information about propagation. But the more you learn about it, the more effective you can be, especially with a small station. If you're limited by maybe some of the HOA things, you can't put up big antennas, you still can go ahead and learn about propagation and how to operate so you can actually maximize your enjoyment of amateur radio within what you have available to work with. So these layers of the propagation called the ionosphere, there's a D layer that's the closest one, then there's an E layer, then there's an F1 and an F2 layer. And the F2 layer obviously is the furthest one out, so that has the greatest ability to go ahead and reflect signals the furthest away. The D layer comes and goes with the sun, but not precisely and exactly. There's usually about 1 hour of difference between when the sun is up and when the propagation on that band goes away. So D-layer absorption happens during the day, and that will not reflect the signals, but they do indeed pass through the D-layer, thank goodness. So like for example, on 40 meters during the day, you're not going to work Europe from here at noon because the signal's going to be absorbed in the D-layer. It's not going to be permitted at those frequencies to pass through to the F1 or F2 layer for reflection. But at night, when the sun goes down, that's when the D layer is available to go ahead and to not be absorbing the signals. So you have better reflectivity at night on 80 and 40 meters. 30 meters is a transition band. Sometimes it feels more like 20 meters, and sometimes it feels more like 40 meters. In the morning, for example, it's still dark to our west. Now, most of us don't have directional antennas on 40 meters, but if you did, then you'd be pointing it to the west, basically, to follow the darkness. So if sunrise is at 6 o'clock, if the sun just starts to peek over the horizon at 6 o'clock in the morning, you're still good on 40 meters to the west, probably till about 7 o'clock, roughly. And then things start to drop off at that particular point even more. Same thing when it comes to the evening. If you want to work 40 meters before sundown here, you can actually work 40 meters. If sundown is at 6 o'clock, you can start working 40 meters somewhere around 5 o'clock, effectively to the east. So a lot of times, like in some of the contests, in some of these contests, you can actually start to work the Europeans or East Coast if that's the flavor, or if you just want to QSO that way, more to the east before sundown on 40 meters. So there is some peculiarities with these type of ionosphere layers that are worth knowing, like this part with the D layer. Most of our propagation is on the F1 or F2 layer on frequencies above 10 megahertz. So On the 20 meter, 17, 15, 12, and 10 meter bands, you'll see really nice propagation, especially this time. We're about a year into the sunspot cycle, the new sunspot cycle. And I don't know if you guys have been on the air, but it's just been wonderful. On a spot basis sometimes. I mean, one day is really great and the next day you wake up, it's not so good. Well, what are some of the factors that influence this? Well, we have a sunspot number and a solar flux. Sunspots are basically a cold spot on the sun. That's why they appear as dark spots to us. And it influences the ionization of our layers of the ionosphere. And that's a pretty important thing. But we also have, with the increased activity, there's also increased possibilities of storms and things being unsettled on the sun, which are not so good with propagation. If you were to have, for example, a sunspot number of 200, a solar flux of 300, and an A and K index of 1 or 0, it would be unlimited worldwide communications on 10 meters, even at night. 2 in the morning, you'd be working whatever you could, whenever you wanted to. Well, that just doesn't work that way normally. There are some times when 10 meters during sunspot maximums can be worked all night long, or at least well into darkness, and it's just amazing. And long path too. But what is the A and K index? Well, the A index has got a value of 0 to 9, and that would be a matter of completely quiet at 0, and you might as well just go ahead and watch TV at 9. And this is based on 3-hour intervals of measurement, and then the K index is a combination. It's some sort of a math. It's not exactly the same math like multiplying 8 times 3 of the A index to get to your K. It's going to be like you'll see between 0 and 400. So obviously we know 400 can't possibly be a matter of 9 times 8 periods to go ahead and get to 400. So it's not the exact relationship that way. But the K index, which is usually typically the larger number of what it is we see, that one is a mixture of the past 24 hours of the A index every 3-hour measurements. So how do we really use this stuff? Well, what we're looking for is the lowest number of both of them. If you were to take, like, for example, an A index of 3 or lower, that's generally pretty good. A K index of 10 or lower, that's generally pretty good. It doesn't necessarily mean that it's going to be bad all the time, but it is something to watch out for. And sometimes we can also have solar flux that doesn't change that much when sunspots change. Now, this is something I really don't know exactly why, and I've actually looked into it and asked. Nobody's got what I consider a satisfactory answer, something to repeat in a few words. But, like, for example, K7RA of the ARRL puts out a propagation bulletin weekly. And James, do you know if you have to be an ARRL member to subscribe to some of these bulletins? Okay. And if you are an ARRL member, I know that for sure. There's a lot of different bulletins. There's a DX bulletin, which will tell you about what's going on in the DX world. There's a propagation bulletin. There is a general ARRL amateur radio bulletin. And those are of some value to actually have come through on your mailbox. It really is kind of nice to see them. But anyway, so when it comes to propagation on these different layers of the ionosphere and the A and K index, you can watch what's going on, and you can also hear on WWV 2.5, 5, 10, 15, and 20 and 15 and 20 megahertz. But for us here in town, it doesn't make much difference. We can receive WWV just about everywhere. It's pretty easy to get, you know. Yeah, exactly. Even on your fillings, you can get the WWV at the right spot if you just tune them correctly. But at 18 minutes after the hour, WWV will publish will broadcast a propagation report. It'll tell you about the sunspot numbers and the solar flux and stuff like that. So that's an up-to-the-minute look at things. But things don't necessarily change right away. So if all of a sudden you have a solar storm and you get that reported, well, we may not see that for a day or two. We may not see that at all because it depends on where it is on the sun when it happens, whether it's going to be pointed at Earth, it's going to be, because sometimes we've seen some of these disruptions in cell phone stuff or in the power grid, and that would be for, a major coronal mass ejection, a CME, that's going to be headed right towards Earth at the time it actually happened, so it's kind of still traveling, and it takes a little time to get here. And that kind of stuff can disrupt propagation quite a bit. It's like all of a sudden you turn the radio on and you got to wonder if your antenna's connected. Well, that might be the time to go ahead and do some more reading about antennas, get your latest antenna up in the air or something like that, because being on the air is not necessarily going to be the best. Well, what about the E layer? That's in between the D layer and the F layers. Well, the E layer is a very interesting one that makes up for some really cool propagation, mostly on the 10 and 6 meter band, and to some extent it will end up being sometimes on the 2 meter band, but for the most part it's most frequently on the 6 meter and 10 meter band. And this is called sporadic E, and it's not a precise thing that you can actually kind of measure in the same way that we can with the solar flux and sunspots and the A and K index. But it is a fascinating mode. And part of the problem turns out to be on 10 and 6 meters many times, especially during the low sunspot cycle, low parts of the sunspot cycle, when 10 meters is not as active as it normally would be on the higher sunspot cycle. We don't listen on 10 meters. Or if we do, we listen, but we never transmit. So that's the same thing on 6 meters. Like 6 meters during the summer, roughly from around April to about August, September is prime time. And the real prime time is all of May, all of June, and a little bit into, say halfway into July is prime time for 6 meter sporadic E. And that is a lot of fun. You could get out there with just a small amount of power and a basic antenna. A quarter wave on 6 meters is 54 inches, for example, so you can make a dipole out of basically 54 inches each way with a center insulator. You can use a quarter wave vertical. You could do anything you want on 6 meters and have a blast. 50.125. Many times we're all just kind of sitting there waiting to see if somebody says something, and somebody calls CQ and we're surprised, and then we answer them. But that's part of what sporadic E is. 6 meters is called the magic band because you never know when or where it's going to be open to. One of the antennas I like to use, for example, on the 6 meter band is what's a Japanese design called a hentenna. It's 1 1/4 wavelength loop that's fed about a tenth of a wavelength up from the bottom for a direct coax feed. And in rough terms, it's 10 feet vertical by 40 inches horizontal in a rectangular loop it's built vertically, even though it is a horizontally polarized antenna. The charm of this antenna is the fact that it's got gain and directivity like a dipole as far as directivity, but gain like a small Yagi, like a 2 or 3 element Yagi, in 2 directions. On 6 meters, we don't know where the band is going to open to or when. So if you had a Yagi, especially like a real killer Yagi, like a 7 element Yagi on a long boom, well, that's terrific if the opening happens to be in that pinpoint location where your beam is. But this antenna acting like a dipole but still having gain will allow you to go ahead and listen to the country. I orient mine so that it's east and west. So people in Wyoming and New Mexico are disadvantaged, but that's 2 states where the population is not that great as far as hams go, and hams on 6 meters. Not only that, generally those 2 states are very, very short as far as propagation goes, so normally propagation is further away than those 2 states would allow anyway. So it's almost like a perfect thing to have an antenna that's oriented east and west with a little null off the north and south for those particular 2 states. So what's close to this on HF? How many people have heard of a skeleton slot antenna? All right. A skeleton slot antenna is really cool because this is an antenna that can give you gain and directivity like a dipole, so it's bidirectional, on frequencies from 20 through 10 meters. Well, that sounds like a Yagi in a way. It does have good gain. It does have some directivity, and it does work on all those bands with gain. Well, the key to that, and part of the problem might be too, is the fact that you need to feed that with open wire line or with 450 ohm ladder line or something like that, and then tune it on each frequency. It is not a direct coax feed. So that's an antenna that's pretty cheap to make. A little bit bigger, it's about 20 feet tall by about 10 feet across. And if you looked up a skeleton slot antenna, if you could manage it, it's an amazing antenna, and it's akin to this Japanese hentenna design. which is coax fed just for one band. So 10 meters. 10 meter sporadic E is a lot of fun too, because you don't know where it's going to open and when, and it has nothing to do really with the sunspot cycle. It has nothing to do with F layer propagation. So sometimes you can end up with very short skip, what we would consider short skip on 10 meters. Maybe 1,000 miles, 800 miles, something like that, as opposed to the typical F layer skip, which would give you 1,500 miles plus for your first skip for the most part. So that's the main modes and layers of the ionosphere for HF operation. Does anybody have any questions to this point for propagation or what we've talked about, or even a sideways comment? Yeah.
You mentioned A and K, and I've never been able to keep that straight in terms of where's it coming from? Is that part of the Earth's magnetic field, or is it something from the sun?
Dave, in my jacket pocket, you should find a folded up piece of paper. Give that piece of paper to the gentleman there, and he can see the A and K index as explained just with numbers and the values, and that could be of some value that way. And more specifically to your question about the A and K,
what do you measure?
well, what we're measuring actually is I guess like an activity level of the sun, a disturbance level. And that would be why there's language in things like quiet, disturbed, active. That's why those type of languages. So it's not just a matter, when a sunspot appears, usually there is some sort of a disturbance associated with it because it's a disturbance on the sun. But not always. And this is the part about this is just so fascinating to learn some of these things because it's not an exact thing. Not everything just adds up to 2 and 2 is 4 and it's just that's wonderful, go have a nice day. It's so fluid with propagation. But that's the direct relationship is either a 3-hour measurement over 24 hours is what the K is and the A is those 3-hour measurements. So, and that just on that piece of paper just shows you the levels that they're talking about. And you could see, like, we hardly ever see something in the 100 plus, for a K. That's really, really disturbed. So, but it's cool.
Don't you mix the ionosound data into that as well?
The what?
The ionosound that they determine MUF with? I think that's mixed into the A.
Well, that's another thing I didn't mention is the MUF. That would be maximum usable frequency, the MUF. And with the greater amount of sunspots, the greater the solar flux, the higher the MUF is. And it's amazing sometimes we could end up with an MUF well over 30 megahertz, during these particular times. And we've had great propagation from time to time. Like when I was in South Dakota, propagation just was awful. And I had to really work hard to go ahead and work Europe. And these guys were generally in a neighborhood of at the noise level to S5 or 6. And some of these guys have got some really nice hardware. And then the next weekend, if I'm not mistaken, the next weekend was CQ Worldwide Sideband. If I'm not mistaken, that was right after I came back from South Dakota. And propagation was wonderful. We all had a great time on CQ Worldwide. How many guys got into CQ Worldwide Sideband? And that's even if you're not a contester. Even if you just would test out your station a little bit, see what it's like to work distant places, or even add to your DXCC totals. You don't have to be a contester to enjoy a contest. What's that?
10 meters was open all day.
Yeah, exactly. And it was just amazing. It was such a treat. I remember, the dinosaur days when I was in California in the 80s, and I had a big Yagi. I had a KT-34XA, 6-element Yagi on a 70-foot tower in West LA, a few miles from the ocean. And we used to point the antenna towards Japan in the contests, and it was just wonderful on 10 and 15 meters, 15 meters especially. So there would be the kilowatt Japanese licenses, and those guys were 20 over 9. So you'd work those guys out because there were not that many of them. Then the next layer was 100-watt licensed Japanese stations. And have you noticed that there are also a number of older Japanese radios that are available, sometimes you see on eBay, that are 10-watt radios? Well, those 10-watt radios were because Japan, for many years, had a 10-watt license. So you'd work the kilowatt guys, you'd work the 100-watt guys, and then what was left was this constant din of 10-watt stations. So, and luckily the Japanese are so polite. You just have to say JA1A, and they would all be quiet except for the guy that happened to be JA1A. So you're taking your best guess on some of these things because you can't hear it. But that's the nice part about the great propagation. And even here in Colorado, where we're not really close to the west and not close to the east, we still have some advantages sometimes in propagation. And it depends. Like, for example, if we're looking to go to the west at the end of the day, well, then you know something? The East Coast can eat our shorts because they have now, their propagation is gone, and we're on the way, with going to the west. Conversely, in the morning, I'm on 10 or 12 meters listening to the East Coast work Europe. And part of the problem is if the propagation is a little slow to get to the Midwest or the western Midwest like we are here in the western area, well, the sun already is getting close to going down in Europe when the band starts to actually open up for us to that area. So a lot of times we'll end up with either a very, very short opening on 10 and 15 meters to Europe or none at all, even though the East Coast got that. And you're listening to these guys saying, oh yeah, propagation's really good today. My dipole at 20 feet and 100 watts, I've worked a dozen Europeans. And I couldn't hear anything. Well, that's common, and James understands that too, even though he's got a nice big tower and Yagis and stuff. You just can't make propagation. That's the problem. Now, if you have a really high antenna, you can open the band before others and close the band after others. In the middle of the band, your signal may not be that much different than the guy with a low Yagi. Low Yagi being 35, 40 feet, for example. If you're in the middle of an opening, your 35 or 40 foot antenna is probably going to work not that far off of a very tall towered Yagi. That means that if you pick and choose your times based on propagation, you can do quite well on the way in today. James, what was the ITU contest, CW, on the way in today? I worked a few guys. Do you know what that was? I don't even know what it was, but it was a Bulgarian contest. It was an LZ contest, yeah. So it was a Bulgarian contest, and on the way in from my truck with an 8-foot whip and 100 watts out of my FT891, I worked Ireland, I worked Netherlands, and I worked Slovenia. So I worked 3 guys on CW on 15 meters on the way in with an 8-foot whip. I think most of you guys have probably got, what's that?
That's 60 mile an hour, right?
That's right, you're right, rolling down the road. I think most of you guys, even in HOAs, have got antennas that are better than an 8-foot whip. So.
Yeah. So Dan, 17 meters was my big mobile band. I worked DXCC in the truck with a screwdriver antenna on 17 because, you know, the propagation is very similar to 20 meters.
That's right.
Except at the very bottom of the solar cycle, 17 is pretty good. It's quiet, the work bands, so that's, when you have the advantage of a quiet band and you have, you know, decent propagation, yeah, small antennas are absolutely amazing. So I was in Wyoming for a long weekend, the first weekend of October, I think it was. I did a whole bunch of summits on the airs. And I worked 2 French stations on sideband on 20 meters, 10 watts with an in-fed half-wave wire tossed in a tree. And they're quiet, right? It's a 5.1, 5.2 kind of signal report, but 10 watts and a very inefficient antenna with no ground plane whatsoever, and 10 watts to France, no problem.
Well, that's a matter of propagation, and also, the fact that you had an attractive call sign, being that you were going to be a Summits on the Air, helped. In other words, people are looking for you. That's what's nice about the Colorado QSO party. You get to be DX for a day. That's why I'm thrilled with it every year. I mean, in fact, I got a few holes in my wall. I want to go ahead and continue to go ahead and get first place plaques. I'll plug those holes. That's why. But no, I enjoy the Colorado QSO party because of that ability to go ahead and be, a poor ham, one that's not going to travel around the world and do DX expeditions, but I get to be DX for the day. Anyway, that's not going to be till September, so we'll talk about that some other time. But James is right about those higher frequency bands. A couple things, too. Antennas are going to be more efficient per their physical size at 20 meters and above. For example, my 8-foot whip in the car is still an entire 1/8 wavelength long on 20 meters. And at an 1/8 wave, there's really not that much difference between an 1/8 wave with a good ground plane and a 1/4 wave. And as you get higher in frequency, that 8-foot whip antenna becomes an even larger percentage of the true quarter wavelength. At 10 meters, it is a quarter wave. So that means at 12 meters, it's close to it. At 15 meters, it's not that far away. At 17 meters, it's more than an eighth. And even as low as 20 meters, it's an eighth wave. So a lot can be done with a very short antenna. Base fed, you know, you don't want to go ahead and feed a non-resonant antenna back at your shack and tune it there back at the coax end, because you'll have additional losses in the coax. Propagation. Anybody have any questions about propagation or antennas? Yeah.
From Colorado, it seems like the most difficult area that I can't get into is northeastern and southeastern Africa and Madagascar, which are two of the 3 remaining CQ zones I need.
Yeah, well,
So-
Indian Ocean is pretty far away from us. That's
Yeah,
true.
yeah. So, but it looks like it's like you're talking about the sunrise, sunset. You know, there's not really a time.
Well, I'm glad you mentioned that, because that has to do with what's called gray line propagation, which I have not mentioned. And gray line propagation is really amazing, because if you have gray line even in one of the 2 locations that you're trying to communicate with, like say it's gray line for you, the way it rides that gray line, the actual signal, is of great value. And there's sometimes a short period of time. A lot of times we can make use of this on 160. We're talking about sometimes 10 minutes worth, 15 minutes worth, 20 minutes worth. We're not talking about a long period of time. We're talking about a very short period of time. So if you just want to go down and turn on the radio and blast away and see what's there, well, then you're subject to whatever it is that you happen to roll up upon when you get there. Otherwise, if you think a little bit about it ahead of time, take a look at some of these, the projection of what the gray line would be. As an example, I have a magnificent antenna for 160 meters, but it's not very high off the ground. It's 65 feet up. It's a 1,100-foot loop at 65 feet. Well, 65 feet is only an eighth wavelength off the ground for 160 meters. But during the FT8X Amsterdam Island, which is within a couple of 100 miles of my QTH being the antipode, the other side of the Earth, in the mornings between around 7 a.m. and 7:20, these guys were 4 S units out of the noise on a speaker, no headphones needed, armchair copy. Why? Because I was in gray line and they were in gray line. So it was double gray line at the same time. Now, when you can get that to happen, that's great. And if you take a look, based on the time of year, you can see where the gray lines will actually be closer together for where you want to work, or further apart. And you could actually pick and choose your times. Like, for example, you're going to find that working Europe is going to be a whole lot easier at this particular time on the low bands because of the increased amount of darkness. So right now in Europe, if we were to go ahead and try to work somebody on 80 meters, I have a good friend, GW3YDX, Ron. I work him on 80 meters often. He's on 3507.5. If anybody ever wants to just listen on that frequency, you might hear him if you've got a decent antenna. Well, he gets on about an hour and a half before our sunset, which is just the beginning of the propagation time. Well, as we start getting into March, in that range, February, March, April, well, by that particular time, the sun is now going to be in the sky a lot longer, and when it's starting to be the right time for him to get on the air with his particular area of darkness, it's still too light for us. So that's why this particular, the fall of the year is probably one of the best times for HF propagation. One of the worst times generally tends to be the summer because we have a lot of thunderstorms. You're not going to go ahead and be on the air on 160 and 80 very much just because of the thunderstorm and noise activity on those bands. It's just awful. So what I even do, I even disconnect one of my big antennas on 160 and 80 meters during the summer because I just don't use it. But during the winter, you can get on and really enjoy yourself that way. But as it turns out to be, as James was talking about mobile on 17 meters, his antenna was very efficient at that frequency because with a screwdriver, it probably was a total of maybe about 10 feet long, a little bit of base loading, and then probably a 5 or 6 foot whip above that. Very efficient antenna. And obviously the ground plane, whatever it is in our vehicles, it is, but that's still helpful. Anybody else for propagation or antenna stuff? Yeah.
Are you going to talk at all or Were you going to talk at all or show a link for the ionosound we have in Boulder?
I'm sorry, for the what in
The
Boulder?
ionosound that's in Boulder
You
and
know,
what it shows us?
I have not. In fact, why don't you offer that? Go ahead. Do you know where that could be at?
Are you able to pull up a browser and show it on the screen?
If I do, I can just step out of the way so that the light's not, so you can
Yeah.
still.
There is a direct link for the Boulder ionosound, but I don't know what it is, and it's hard as heck to find it. But there's a website, hamwaves.com.
Yeah.
And he's got a ton of information on everything. But in his HF propagation section, there's an ionosound tab. And it tries to figure out where you are from your IP address, and it gives you the nearest ionosound. And that's good because sometimes the Boulder ionosound goes down, goes out of service, and then this website will show us Idaho as the next closest one. So this is almost real-time information. I think it's every 10 minutes that it updates, and it sweeps the ionosphere. It's basically a radar pointing straight up. Hamwaves.com. And it's giving you real-time information on what, if you click right there, real-time HF propagation in the top center, and then look for, there should be something about ionosounds. I don't know if we have to scroll down or not. Yeah, ionogram information on the left, middle left there. That should, scroll down. So that's a static picture there that explains what you're looking at, but if you go up, it's not filling up here for some reason. Normally, this would detect where we're at and say, oh, here's an ionogram from Boulder. It's not filling in right now, of course, because I'm trying to demonstrate it, but if you guys write this down or bookmark it, it normally works. We've been experimenting a lot with NVIS, Near Vertical Incident Skywave, recently, and this has been very valuable for that. But what it shows is looking straight up and listening straight down where you're getting reflection. And then based on that, it calculates your maximum usable frequency for different ranges, and it displays that in a chart on the bottom.
Well, does that mean that this is, since it's straight up and straight down, is this primarily an NVIS type of a tool?
Well, if you go back to that picture right there, that static picture, it gives you an actual measurement of straight up and straight down. But then at the bottom where you see MUF, you see a string of numbers there. And for different distances in kilometers, it uses an algorithm based on that vertical incidence. It uses an algorithm to compute at different frequencies how far out you can reach.
Yeah, and obviously that's why, it looks like for the NVIS stuff, that's why we're looking at mostly stuff that's 4, 5 megahertz, 3 megahertz, and this chart only goes up to 10 megahertz.
So on this particular moment of this chart, which is a static one from some time in the past, the max, if you look at the top left number, F0, F2, that's the highest frequency you can use straight up off the F2 layer, which at that time was 4 point some megahertz.
Do we know what time of day this is showing?
It's going to be in Zulu time up at the top.
Where's it at?
Date and time will be, so this is out of Alaska, first of all. This is Gakona, Alaska, November 10th.
So this is more just representative than anything else at the moment.
Yeah. The one that normally will populate above it would normally be Boulder. It's not working today because I'm trying to use it. But normally we get a thing from Boulder, and it's every 10 minutes.
And right now we are 6 hours away from Zulu.
Yeah.
So basically,
Yeah.
right now it is. Let's see. So so it's 10. So it'll be 1800 Zulu right now. 1840 Zulu right now.
So for the vertical, straight vertical NVIS for this region, it's typically between 2 megahertz at the, right before dawn at the lowest point. It can be down around 2, and although we usually don't lose 80 meters anymore for NVIS now with the solar cycle getting better. So we can usually use 80 meters all night for NVIS local work. And then right at dawn, it starts to come up. And lately, it's been hitting over 10 megahertz. So for our purposes as amateurs, that means 80 meters, 60 meters, and 40 meters is what we're interested in working for NVIS. And we've been going into the canyons, like between canyons and talking.
Yeah, you guys just recently
Yeah.
did a test on that.
Pooter, between Pooter and Big Thompson.
Yeah, and you know, NVIS is not my thing, so I'm really glad that you brought that up as a valid propagation mode, because sometimes not everybody is interested in working as far away as possible. Sometimes we're interested in working beyond the range of line of sight VHF, UHF, but not necessarily Europe.
Right, and you're familiar as a DXer with having a dead zone where you can talk ground wave for a few miles, and then you can talk to California or New York or Madagascar, but there's a big dead zone in between, and this NVIS will fill that in.
Yeah,
So-
and that's why these frequencies are especially usable for NVIS, because on 10 meters, just as an example, to take one of the worst examples of HF being low to the ground, all you need to be is, 16 feet off the ground is an entire half wavelength, and that gets you into low angle of radiation. Whereas something like 10 to 20 feet off the ground on 80 meters still puts your signal straight up.
Yeah, Bob's running 5 feet off the ground on 80 meters. I just ran 6 feet off the ground on an HF Aries net, and I was in the Pooter Canyon at Stevens Gulch with an antenna 6 feet off the ground talking to Pueblo, Colorado Springs, and Grand Junction
On what frequencies?
on 80 meters.
And then what were the signals like?
S9 and 0 noise floor.
See, there you go. And that's something that's close enough to go ahead and still be useful, but not something that you're going to work with an HT.
Yeah.
Well, I mean, unless you're going through repeaters, but this is still direct from
Yeah.
radio to radio.
And we're going to areas where there's no repeater, no cell. Dave, if you go up, there's another tab for historical data, and we might, on the left, historical anagrams. Go to station lists, the blue tab station list. Okay, that's
Not
why.
today.
So the whole thing's down. That's why we're not getting anything.
But I tell you what, why don't you go back to the ham wave site? And I know James
Yeah.
had something he wanted to put in there. James, what do you got?
This actually went back to Dick's question about, there's certain areas I want to hit and I can never hit them. So one of the things that I use, especially for that kind of stuff, is propagation prediction engines. And most of them are based on free code called VOACAP. I subscribe to, prediction engines can be really complicated.
And VOACAP is VOACAP.
Correct, VOACAP. I use two different mechanisms for figuring this out. Personally, my station at home, I run the DX Lab suite, set of station control and tools and logging and all that stuff. It's ugly and extremely functional, but it's got a really nice prediction in it. I also subscribe to K6TU. K6TU has built a beautiful propagation service in a WordPress website that you can subscribe to.
And that still displays as a bunch of like not graphical, but like grids, right? I mean, charts, I should say, right? That's the way he sometimes gives that away for free,
Yes,
partially as an
for
advertisement
DXpeditions.
on major DXpeditions. So if you go to the webpage for the DXpedition, you can see K6TU's propagation for that particular spot. Go ahead.
Yeah, exactly. And so it'll show you hour by hour, band by band, what your likelihood is of being able to contact that. And you put in there what kind of antennas and power and stuff that you're using and antennas and power that they're using, and it will show you both directions what kind of signal to expect based on the data, the current data. It's a prediction still, right? It's live, but it's pretty darn good.
And there's others that are like you can go to for free, like the DX Summit. If you were to go, let's just say there's a station you want to work, a DX station. You put For one thing, you tell the DX Summit website your grid square, like Delta November 70, DN70. You don't have to go past that with the individual letters for 6 digits, because DN70 is fine for HF. So you tell it where you're at, then you put the call sign of whatever it is that you want to find out the propagation to, or you can just take a look at whatever is displayed on the DX listings. You can go ahead and just just left click on that, and you'll get a chart that pulls up and it says show VOA cap predictions. You click on that, and then they give you a big circle view.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.